Welcome back, everyone. In this lesson, we are going to talk about how we can use the Apollo client to replace Redux in terms of managing our local state inside of our application. Now, up until this point, we've only used Apollo to fetch data from our GraphQL server. But it turns out that Apollo can actually also help us manage, store, query, and mutate local data. And it's going to follow pretty much the exact same format in terms of pulling it out and then setting values into the local state as we've been doing here in terms of our queries to our GraphQL backend. Now, the reason that Apollo does this is because it wants consistency. And the reason why you don't want to mix Redux and Apollo together is because you want all of your code to be unified in terms of that unidirectional data flow, and you want a single source of truth. So if, for example, we were using Redux in certain parts of our application and Apollo in others, well, it would be awkward because what happens if we pass some data inside of our GraphQL, right, query, we fetch some collection items down, let's say another component modifies it, and it stores it in Redux. Well, what's the point of that if that data is not the same in our backend? So that's the main issue with using libraries like Redux and Apollo together. You mainly want to leverage using Apollo as your main source of local state management. And we can actually do it. It's a little bit weird because it's different from what we might be used to, but I promise you that with practice, it will definitely make sense. Now, for us to do this, the first thing we're going to do is we have to instantiate some local value for our state. So pretty much like the initial value of our reducers that we were used to setting up, we got to do something similar with our local. So how that works is we actually do it on the client. And the client actually leverages the cache in order to do that. The cache is the local storage. Now, how we do this is we can actually say client.write data, and we want to do that in the index.js because when our app initiates and our client gets created for the first time, we want to immediately write this data into our client. And we want to instantiate this with some data as the property, and then the value of data will be the object that has all the keys that we're trying to store. So for us, because we want to replace the cart dropdown hidden value, we're just going to say hidden. And we're going to set this by default to true. If you want to be more explicit, you can say this is cart hidden. Actually, let's do that. Maybe it's a little bit more explicit, so let's just say cart hidden. Now that we have this cart hidden true value, we actually need to figure out how we can make a mutation that lets us modify this. So we've seen queries. The other thing we have access to is mutations. And mutations is pretty much as it sounds, it mutates some data. So what we're going to do in order to do that is we have to make a new folder that is going to hold the code that contains these mutations. And we're going to put it inside of our source. And this new folder is going to be called GraphQL. Now inside of this GraphQL folder, we are going to make a new file called resolvers.js. And why it's called resolvers is because it is this object that we can pass to our client that lets it know what values to resolve depending on what mutations or what queries get called from the local client side. Now, if that sounds confusing, don't worry. Once we write it out, it'll make more sense. The first thing we're going to do is we're going to import in the GQL tag from Apollo Boost. And what we're going to do now is we are going to actually define the type, i.e. the schema that this local side is going to use and get access to. So as you remember, when we looked at our schema inside of our actual playground, these are the mutations and queries that were available to us from our backend. Now, of course, there were no mutations here. There were only queries, but this schema is actually defined the same way that we're going to define it here. And what we're going to say is we're going to export out some const called typedefs, standing for type definitions. And this is going to be equal to our GQL tag, where we're going to add any more values or types that we want the client to have access to. So of course, what we're going to say is extend type mutation. Now, extend means something different inside of GraphQL. When we extend, we're actually saying, I want you to extend the existing type of mutation that might exist in the backend. So in the backend GraphQL server, there is also this mutation that was written for any mutations that we might have access to. Now, because we haven't written any mutations, as you can see in our schema of our database, we're not going to extend into anything really. But if in the future we ever do add mutations on the server, we don't want to have to modify our code here. So by extending it, GraphQL knows that if there's nothing, that's perfectly fine. Otherwise, we're just going to add new mutations to what Apollo is aware that it can call. Now, the one that we're going to add is the toggle hidden, because what we want to do is we want to toggle that hidden value. Now, because this value will always be a Boolean, either true or false, that's what this mutation is going to return. So inside of this mutation definition, we're going to say that there's going to be this toggle cart hidden mutation that always returns a Boolean. And we signify that with the exclamation mark. Now, as far as the actual resolver is concerned, we are going to write it as this object. And in this object, we're actually going to define what are mutations and what are queries, as well as what additional types we might have on our client-side cache that Apollo has access to inside of this object. So the first thing we're going to define is the new mutations we have access to. So here what we're going to do is we're going to say capital mutation goes to this object where the key of the actual mutation is the mutation we're trying to write. So in our case, it's toggle cart hidden. Now, in case you're wondering why this one is capital and this one is not, it's because this one is a type definition, and type definitions need to be capitalized, or ideally they should be. They don't always have to be, but they should be. This is the actual mutation definition inside of our JavaScript. So this one can be the regular camel case that we're used to. Now here what we're going to do is we are going to actually write out this function. And this function that represents our mutation gets 4 arguments. Now I'm going to walk through what they are, but let's actually write them out first so we see what they look like. The first one is root. The second one is args. The third one is context, and the fourth one is info. Now we use these underscores just because that's how they do it inside of the Apollo docs. But this root object represents the top level object that holds the actual type. What do I mean by this? Well, if we look at our playground, if we look at this item, we know that this item has this collection key. And this means that this item belongs to this collection, which is why we're able to query the items from calling the collection itself. And on the collection, it also has this items key that gives it an array of items, implying that there's a relationship between these two types, which is a backend concept. Now, what this means is that from the item, if we were to write a resolver on an item property on our front end, for example, for a property that might not exist, like imagine if, say, we had some other thing that we might want to resolve from our item, right? We would write it like this. We're extending the item in our backend. And let's say we have some additional property that we add on here called parent's ID, right? I don't know why. Let's just imagine that. Inside of here, if we were to write this resolver, we could actually write it like this. And when we call this function, where we call the property parent's ID, this root object would represent the parent, which for us is this collection because of this relationship. So that's all you really need to think about if you were to ever use the root. Now, in our case, we're actually never going to use it, so there's no real reason for us to dive too deep into it, but just know that that's what this object represents. For anything else at the top level, so in our case, we're at the top level because our mutation is at the very highest level of our actual cache object. This is just going to be an empty object. So we're never going to use it, but we need it to just know what it is. The args object represents all of the arguments that we could possibly get access to inside of the mutation, meaning that if we look at our collection container, when we passed this title into this query of get collections by title, this argument object would be equal to an object where title goes to that string. So arguments is pretty much the variables that get passed into our mutation or our query. That's what this arguments object is. The third is the context. And the context is the thing that the Apollo client has access to, which includes the cache as well as the client itself. So for us, if we need to make any writes to the client, we can do that and destructure it off of the context. Otherwise, all we ever actually need is the cache object. The last one is the info object, and this one just has information about our query or our mutation, but this one we're never really going to use. I'm going to link for you a link to the Apollo docs so you can get a better look and more thorough explanations and instances and examples, right, if you want it. In our case, we don't need it. And honestly, the reason why it's written this way is just because this is how this code is actually written in the backend. And Apollo wanted to be consistent with how people write GraphQL servers in the backend. So in our case, all we really need to remember is that we need the args and the cache, and these are easy to understand. So what we're going to do is we actually first need to read from our cache that initial value or that cart hidden value that we are setting and changing, because we need to flip that value every time the toggle cart hidden gets called. So it's going to be the same way that we've made queries inside of our other containers. We're going to define this const get cart hidden query, which is equal to GQL and us just simply fetching the cart hidden property. And in order to specify to Apollo that this is on the client side, we use what's called a client directive. This @ symbol followed by the client key will let Apollo know that anything calling this query is looking for this cart hidden value on the local cache, not in our backend. So that's what's really cool about this. So now in order for us to actually read from our cache, we need to know that what we're getting back is the data object. And in order to actually do the query, we'll say cache.readQuery. And read query gets an object where the query is the actual query we're passing in. If we wanted to pass values like we did into this query, this get collections by item, there's a variables property that comes in as well that we can pass it in like so, right? Which would be the object where the variable represents the same way that we passed it inside of here, right here. So in our case, we are just making this query for get the cart hidden. This will come back to us as the data object. And of course, the query itself, cart hidden, will be the property on the data object that has the Boolean value that we want. So we'll just destructure that off right here. And we'll say it's cart hidden, right? That's what it is. And then what we want to do is we want to now update our cache with the reverse value once we've gotten the value. In order to do that, we say cache.writeQuery, which is the opposite of read query. And what we want to write to is we want to say the query goes to that same query. We're trying to get that same location in our database that we pulled from. And we want to update it with our data of that cart hidden goes to the opposite value of our cart hidden value. So we're reversing the value. You can see the syntax kind of like when we call set state and we pass in the property and the value that we want to set it to, right? It's very similar. You pass it as an object where the key value is what you're trying to change on your cache. Finally, what we'll do is we will return that new cart hidden value that we have reversed like so. So that anyone calling our toggle cart hidden resolver is going to also get back this opposite Boolean value if they want to do something. So now we've defined our resolver and we've defined our type defs. We have to bring this into our index.js and put it on our client. So let's import in our resolvers and our type defs from our new folder, GraphQL/resolvers. And we're just going to pass them in as themselves in this object. So we'll say type defs and resolvers. And now our client has access to these new mutations that we just wrote. So I know this syntax is a little weird and it's going to take some getting used to, but we'll honestly write enough of these mutations that you'll get used to this pattern. It's really just a pattern that Apollo expects. So now that we've written them, let's actually use them inside of our application. And through using them, hopefully it'll become more clear as to what's happening and as we write more. Because this is really just the case where the more we practice, the better we'll get at it. So let's implement this in the next lesson.